the clock has struck 1. Hello, everyone. My name is Sarah McAnulty. I am the Executive Director of Skype a Scientist, and I will be your host today and most days for Skype a Scientist Live. Today, we are super lucky and excited to have Shareef Jackson joining us today to talk all about engineering and the engineer in all of us. Just some housekeeping. This coming week on Thursday at 1 p.m., we're going to be talking about how old rocks are and how old we can figure out those rocks are. That will be Thursday, 1 p.m. with Peter Martin. We'll be looking at rocks on Earth and rocks on Mars, which should be super cool. So join us for that. But without further ado, I'm going to introduce our guest expert. Shareef, thank you so much for joining us today.
Yeah, thank you for having me. I'm really excited to be on this call. Let's get some questions.
Awesome. Yeah, so everyone in the audience, do not be shy. These sessions are for you. So if you have any questions about Shareef's career, engineering, science, now is the time. So feel free to submit those in the Q&A. And then after Shareef introduces himself, we will talk all about your questions. So how'd you get to where you are?
Oh, it's been a journey. It has been a journey. I guess starting from the beginning, when I was younger, I would always take things apart. No real reason why, but things like remote controls and that toys and that kind of stuff. And I just thought it was fun, try to put it back together, but before my mom got home, like that kind of stuff. And I didn't really see that connected to anything I could actually do, though. When I was younger, I'm the first person in my family to go to college, so I wasn't really aware of anything outside of that. Even though I was always a good math student, I never really saw that connection. But then when I was in high school, I found out about engineering as a major. Kind of like applying the math and science that I was already, had a love for into an actual career of building things and taking things apart as well. So I decided to pursue that in a college. So I ended up doing that for undergrad and graduate school. And then I worked for several different companies as a engineer and a data analyst. So I ended up moving more to the software side of things, but I was still using the same skills, that I used in college. And I always tutored on the side as well because I had a lot of help when I was younger. So I always served as a math and science tutor to both upcoming engineers and people that just needed help. And that turned out to be something that I really got a strong passion for. So much so that 4 years, almost 5 years ago now, I actually started my own tutoring business. So that is my full-time job now, is tutoring students in math, physics, and chemistry, and test prep work. So I feel like I'm doing kind of like what I was meant to do. And it all comes back to taking things apart.
That's awesome. So when you were working for after grad school, what kinds of things were you building, designing, making?
Yeah. A lot of it tended to be constructing databases of products. So I worked for different consulting companies, and typically they would bring us in if they had a bunch of machines and a software and they didn't quite understand what they had, how it works, how old something is. They just didn't have a good catalog or a inventory of everything that the company had purchased over years, even decades. So I would be the kind of person to come in, help them to analyze what they currently have, and then to make suggestions about whether they should keep the stuff, whether they should get rid of it, whether they should upgrade it or combine it. All those situations came into play. This was especially important because I started working, I left college right after 9/11. So there were a lot of like companies, especially in the New York area, which is where I was based out of, that were really analyzing their infrastructures to make sure that they didn't have everything in one place. You
Right.
know, so
Yeah.
yeah, it was fun.
Cool. So we've got a question from one of our audience members. What was the thing that made you decide to become an engineer?
Oh, well, yeah. As I said earlier, it really was. It seemed like it was the application of a lot of the math and science that I was learning in high school. Um, so I had always been a big fan of video games, for example, right? And it was always interesting to me, like, how does a cartridge work? Obviously back then we were gaming with
Well,
cartridges.
none of us
I know I'm dating myself a
yeah,
little
yeah,
bit,
yeah.
yeah. It was just interesting that I would plug something into this system that looked like a toaster, like the Nintendo Entertainment System, and it would just work. So one of those things that I tried to take apart was cartridges. I wanted to see how they worked. And when I was looking up what engineering was, and like, this was like, 1997, 98. So it wasn't really, the internet wasn't really the way it is now, where like you could just get a bunch of, there was no YouTube, there was no like, like even college websites didn't really have a lot on them. Right. But what I did find was people building circuits and people building things that were already parts of the toys and the video games that I was already a big fan of. So like that's what really made me kind of narrow in and say this is what I want to pursue.
Awesome. Yeah, tinkering as a kid was one of the first things I did that was like science related. Like taking apart toys and putting them back together was really fun. I'm a squid biologist now, but definitely kind
Hmm.
of pushed it toward the science path. The next question is from Anita. What are the major branches of engineering? Like we hear about chemical engineers and environmental engineers and software engineers. So like what does the landscape of engineering look like?
Oh, there are so many. I think that there are kind of what people would think of as the classical engineering branches, like electrical, mechanical, ch- chemical. But there's so many other ones. I have friends that are nuclear or biomedical engineering or like material engineering. There's a lot of different subsections because there's a lot of different needs that have come up, and as a systems in the world have become more complex, right? There's like more subsections of engineers that really focus on those needs. So I would say that the like classic ones are the ones that you'll find at almost any school that offers engineering. The other ones kind of depend on like where you go. Now obviously, if you're looking at a technical school like a MIT or a Caltech or a Georgia Tech, they're going to have everything, right?
Right.
Because they are technical schools that where like that is their focus. But like if you're going to like a more like rounded school that has an engineering department, they might only have like those classic ones and like a few others. So it
Right.
kind of depends on like where you're looking at.
Cool. The next question is from Mike. What role has mentoring played in your career?
Oh man, that's huge. Huge role. Engineering is very difficult. I'm not going to sugarcoat it. Especially in college, it's a very demanding major, not only in terms of the content that you're doing, but in terms of the curriculum and the amount of classes that you have to take. I used to always joke to my friends in college that like you never saw engineers on the main green tossing frisbees around because we were in the lab,
Yeah,
you
sure.
know, for like most of the time. So yeah, I definitely had some mentors. But the one interesting thing that I found was to not only look for mentors that are directly in your major. I definitely had some, but also like being a African American in a space that was much less diverse then than it is now. I definitely wanted to make sure that I had some people that I could connect to on a cultural level. So I made sure to get so some like a mentors that were also African American, but outside of engineering, so that I could talk to them about the cultural situations that like I was going through at that time, and that the world was like going through at that time as well. Also, I was a part of the National Society of Black Engineers, so a lot of the upperclassmen, right? So like when I was a freshman and a sophomore, like the juniors and the seniors absolutely helped to like a mentor us. And then as I became a upper classman, I like mentored, the younger students that were coming in as well. And as far as my career, yeah, I've been lucky enough to, have worked with and be mentored by some really fantastic folks, some that are engineers and some that are not, because it's really more about the personal connection and getting with someone that can inspire you and challenge you. And that doesn't necessarily have to come from someone that has your exact career path. So like mentoring has played a huge role in my career.
Yeah, that's an awesome answer. Thank you. The next question is, I believe, from a teacher. I have a lot of students who are avid gamers. Do you have any suggestions for how to harness their passions in a middle school class that will lead them to
Mhm.
success?
Yeah, a lot of my tutoring is focused around video games, and I teach a video game class. So I definitely harness a lot of this. Um, Depending on what you're focusing on in your class, there's pretty much applications to any STEM field within games. As much as I'm not a big fan of the video game Fortnite, it's really great for explaining like physics concepts of momentum, and forces, and like why you're building things at like an angle versus vertical versus like horizontal. So I've had like Fortnite games where I paused it and I've kind of drawn out, like why these things work actually mathematically. Any games that like involve, food are great chemistry ones. Right. There's like a ton of games that you have to like either create food or like eat different food to like recover health, or like or like or like magic. Great for chemistry. And like any games that involve different life forms or like a different planets are great for like biology, right? Can this weird looking thing actually survive, right? Or like how does it reproduce, how does it breathe, so like there are so many great creative ways that like you can use. And it also ties into game design and narrative, because the people that build these games have to think about that stuff, right? They have to think about like a plausibility of in the world they created, in the same way that a book author or like a movie writer has to think about that as well, right? Just because they're creating a world that does not technically exist doesn't mean that that world doesn't have its own rules. So
Totally.
yeah, I think it's a great way to like harness it, is like ask what games that they're like that they are playing, and then either play them yourself and look for those like concepts, or if like you just Google it, there's like ton of people like me that have already written and done YouTube videos on this stuff as well. So
That's
yeah, you
awesome.
can definitely harness that stuff.
Cool. I think there's also a community on Twitch. I haven't done much on Twitch before, but
Mhm.
it's effectively like you can live stream stuff. And so
Oh yeah.
there's a big community there of science communicators as well. So maybe a scientist will be playing a game and then talking about science that's unrelated to the game, or maybe they'll be using the game as an explanation, just like you said, Shareef, like talking about chemistry or evolution or all sorts of stuff. So there's a lot of content out there that will connect video games to concepts that you may be talking about in the classroom. And so unfortunately, I don't have any specific users that I can point you to, just because I haven't gotten too into that community, but they definitely exist.
Well, I have one user myself.
Yay!
Yeah. I actually just started a YouTube series called Equation Play, where I'm doing these short, like 1 minute clips where I'm feature a section of like a video game and I talk a little bit about the concept that the game is like performing. So I've done them on some recent games like Cyberpunk 2077 and Spider-Man Miles Morales, and a Control. And I've talked about things like inertia and forces and electricity. So yeah, there's a lot of good stuff there.
What is the link that people can go to or look up? Because I'm gonna that.
Yeah, if they just go to equationplay.com, it'll link to the YouTube playlist.
Great. I just put that in the
yeah, or that username on Twitter, Instagram, or TikTok, and all the videos will be there as well. So
super.
Yeah, yeah. But no, there's like a lot of people that are like doing this kind of work, because you have to go where the people are, and a lot of times I feel like people think that science can only be learned in sort of the way that they've always learned it, with a big dusty textbook and breaking out your logarithm tables and all that stuff, and like things evolve, and it's just more important that that like people learn it than the medium that they learn it with.
Absolutely. I completely agree. Yeah. And meeting people where they are is something that we try to do at Skype a Scientist as much as we possibly can. So yeah, that's super important advice. The next question, one more video game question, is from a user called Transfiguration. What is your favorite video game and why?
Ooh, good question. Good question. So my favorite video game is Super Mario Brothers 3. And the reason why is my favorite is because it came out near the end of the Nintendo Entertainment System, so Life. And when you look at how much it stretched that hardware from the original Super Mario Brothers in 1985, it seems like it came out on a different system. I mean, it is amazing in terms of the graphics and the music and the worlds. And also, it's one of the games that really had that feeling of you never know what's around the corner. Like there's some levels where you might fly, somewhere you might swim, and like this is like when this was like still new to games. Like most platformers, where you just running on the side of a screen and jumping, and that's it. So I feel like it like really probably the biggest jump for a franchise I've ever seen in terms of like what it does and what it like offers. I play through it at least once a year, and it's still fantastic. And not a lot of games from that era hold up that well, but I think that like this game holds up supremely well, and will always be my number one game. And also, one of the few games I remember getting when it came out. Like we didn't get a lot of games when they came out back in the day, but I remember running through, again, this is going to date me, right? But running through Toys R Us and looking for that slip, because like you had to get the slip, you had to bring it to the cashier, and then bring it to their like bulletproof cage or whatever they had, where like they would actually give you the cartridge. So yeah, that was like a great memory of mine, and just playing that for like a very long time. And yeah, so that's my number one.
That's a good answer. I have been playing that game a lot during the pandemic on my Switch, because you're right, it totally holds up. Like the difference between that game and the Super Mario Deluxe U, I think is the other one I've been playing.
Yeah,
It's remarkably similar.
one.
Like there's differences, but like I feel like I'm playing a similar game just a couple generations later, and it's just so good. Okay, let's see. Have you ever built a game yourself?
Yes, I have. I built several small games. I haven't built any like commercial games or anything like that like would be for a sale. But like a big part of my engineering curriculum at Brown was, to take like computer science courses. So like probably my favorite project is we had to build Tetris, which seems like, oh yeah, it's just blocks falling. But when you're controlling everything, like you see how you have to think about every possible thing that a user can do and incorporate that into the error handling, so it was like very challenging, but the cool part is that you get to play your results, right? And it's really easy to see like, oh, I forgot to like do this, or this works 90% of the time, but like if the user presses this weird collection of buttons, it like crashes things, you know? So like you have to take care of like that. So like, yeah. And then, yeah, I have tons of books on like video game programming and stuff. Because like I have tutored some college students that like want a more direct application of it. So like I've built games, you know, with my students as well. So
Sweet.
yeah.
Cool.
Mhm.
What is your favorite thing that you've ever designed or made?
Ooh, favorite thing ever designed or made? That is a great question. Um, I'll say one thing that comes to mind is when I was a senior at Brown. So a senior, about to graduate. I had a final project in one of my engineering courses, and you basically had to. It was up to you. It was like it was like, what do you want to do, right? And my partner and I, what we did was we got a RC car, so like a radio controlled car, and we sort of ripped the guts out of it, and we found out that we could connect it to the computer and issue commands to it, right? So we connected it to like a really simple kind of like Visual Basic thing, and we wrote a program for it that basically we basically created like a Roomba, like essentially, right? This was way before Roombas were a thing, right? But like it navigated an obstacle course on its own, and just it was really it was really funny mistakes at the beginning, right? But to see it actually happen and work was really really awesome, and like if it felt really really good to like accomplish that. And that's, I mean, that's in general what science to me is. There's really difficult challenges, but the end result is, one thing I specifically like about engineering is because a lot of it involves like physical, tangible things. Like your end result is something that like you can actually show someone and say, there it is. So yeah, that definitely one of my top things there for sure.
That's so cool. Have you ever seen, this is a bit of a tangent, but have you ever seen this YouTube video of this little robot that is carrying around a container of Heinz tomato ketchup, and it's like driving around and just like causing havoc by squirting ketchup all over the
No,
it's,
I'm not.
it's one of my favorite videos of YouTube.
I'm
It's
not.
also a bit of a like, this is dating me type thing. I think it came out in
No.
like '07. But anyway.
No, anytime I see robot videos, it's those Boston Dynamics videos of
Oh
these
yeah.
robots that are gonna take over civilization. Though I did see one where they were dancing, and they were dancing like better
Real
than I
good.
can. So it was,
Definitely better than me. Yeah.
yeah, yeah. So I don't know if I'm gonna have to dance battle a robot for the future of civilization, but it might happen.
If that relies on me, we're in trouble. I can tell you right now, those robots are doing a lot better than me. Yeah, I've already, those robots are already reasonably intimidating looking, but when they start dancing, I'm like, it's all over. Like
All
we're
over.
we're doomed. Okay, the next question is from Anita. What's your advice for high school students when deciding which type of engineering to pursue?
So I think high school is a little early to think about the type. Typically with engineering, you don't have to declare which one you want to do until the end of your sophomore year. Most engineers take the same courses, like the same kind of like core engineering courses, their freshman year and most of the sophomore year. So I would say not to stress too much about the specific kind of engineering as like a high schooler. If you're interested in the concept as like a whole, though, I would start as an engineer because it can be easier to start in an engineering program and switch out of it than try to switch into it, because there's a lot of core courses that you might have to take, and it might extend your time at the university. So I wouldn't stress too much about the type as like a high schooler. Just focus on being an engineer.
Yeah, I think there's a lot of pressure on kids in high school to like have a very clear idea of what they're going to do either next or for their whole lives. And this is also true in biology. Like whether you're going to be a chemist or a biologist or a physicist, like the classes you take freshman year are the same. So, tell your students that, they can explore in college, and to not like put the weight of the world on their shoulders this young. Um, yeah, that's great advice. Okay, the next question is from Eric. Eric is an elementary school teacher teaching fourth grade in Myanmar. And he wants to know, what grade level would you recommend to introduce coding to students, and what language would you recommend starting with?
Oh man. Honestly, it's never too young. Uh, and I'm not saying that you want to give a first grader a C# book or a Python book or anything like that, but the concepts of coding, which are, making decisions and thinking in terms of cause and effect, is something that you can start early. I think fourth grade, you can definitely start. I usually like a thing that like MIT has done called Scratch. And there's some really cool tutorials that like they've done. It's like a free program. It's like very visual. And I think that you want to focus on those younger ages. You want to focus on the concepts of what programming is. Like, if this happens, then that happens, right? That's what you want to like focus on. I wouldn't focus more on actually writing code until a little older. But like I also think that one thing that people struggle with when they get into computer science is they start trying to write code without understanding the concepts behind why you're writing it, right? So I think focusing on the concepts of why early on will like help them when they get a little older and start actually having to write code. So,
Yeah, and something I wish somebody told me when I was, I don't know, even in high school, let alone fourth grade, is how much coding is everywhere. Like as a squid biologist, I should have learned more coding earlier than I did. And so when I ended up having to use coding, I was just like taking bits and pieces that other people had made and making like a Frankenstein monster of science. And so like having the actual understanding of coding earlier would have been useful for me. So
yeah, exactly. So like I would go to scratch.mit.edu and I would check out there. I think it's a fantastic site that I've used with some of my younger students in the past.
awesome. Thank you. Eli would like to know, describe your favorite science teacher. And they also say least favorite science teacher, but let's not do that because
Yeah, let's not do that.
positive. And like what about your good teachers like helped you? Like what was great about them? What did you like about them?
Yeah. Let me see. I'm gonna pivot a bit and give a math teacher, if that's okay.
Yeah, sure.
Because it's kind of like, the same thing. Um, so I had a teacher, Miss Foster, who I'm still in like communication with. And she was my pre-calculus teacher in high school. And she just brought this like energy and passion to the subject where I feel like she didn't treat it like it was an abstract above your head thing and like it's like, oh, I am giving you this knowledge, like a kind of like a 10 commandments kind of thing. She kept it really fun and really interactive and always connected it to real world things. And I think that like that's something that a lot of classrooms don't have. And it's not always the teacher's fault because a lot of times they are sort of like shoehorned into doing a very specific like curriculum that they can't control. But I could tell that like Ms. Foster had the freedom to really make sure that we always understood why things worked. Like, why is it important to like learn this like equation as like opposed to just learn it because you're going to be tested on it,
Right.
so it really, I think, started my kind of science communication journey without even knowing it, right? Because I always left class thinking that math and science were useful, whereas I think a lot of people, if they don't end up in classrooms like that, they just see it as a task that has no connection to their everyday life, even though every day everyone uses math or science without thinking about it and like experiences it, right? But like you need someone to actually call that out to you and like help you to like do that. So shout out to Miss Foster. She is great.
Awesome. The next question is, could you elaborate on the following sentence on the blog? And I don't know if this is on the Skype a Scientist website or your website, but
Mhm.
Shareef's culturally relevant communication style helps break down science, gaming, and math in a way that an average person can understand and appreciate. Could you just talk a little bit more about that, like mentality?
Sure. Yeah. So culturally relevant, right? So that basically means that as I just talked about, math and science are typically presented in a certain way. If you look at older math in like a science books, they're written, I think, from a more authoritative perspective, where it's more like you need to know this because my teachers taught me this, because their teachers taught us this, because it's important,
Right.
right? Culture relevant means that I'm actually connecting to the culture of modern students and saying, this is why this is important, right? You don't just learn the quadratic equation just because you have to learn it. This is why you learn it, you
Mm,
know, and always making sure to like connect it to things that like an average student would experience. And to be honest, we were all handed a gift because all these kids have smartphones. And these smartphones are like any scientific concept that you can think of is in this device that they all have in their pockets, you know? And like, I'm not talking about them actually like looking it up. I mean, how a phone actually works, you know? So always trying to connect to where students are. And the like, and, and like the culture part is also important to make sure that people don't think science is just, you know, from dead white men, right? That there's been a whole world of people from various gender identities and various cultures that have contributed to science, but it's typically only presented from like a Eurocentric perspective. So also try to break down those walls and like make sure that if you are a young black or brown kid growing up, you know that there are people that look like you that 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 like help to create this as well.
awesome. And for anyone for whom like the concept of teaching science or experiencing science in a way that's not the Eurocentric approach, I recommend a book called Braiding Sweetgrass. It specifically focuses on Native American approaches
Mhm.
to ecology. That's really what the book is about. But it is a great introduction to like thinking about ways of knowing. So, like how we learn things about our environment, how we learn things about science broadly, and share that knowledge from generation to generation in a way that's quite different from the way we learn in school in the US and in that, yeah, Eurocentric way. I think and it's also just a good, interesting book. But um, Braiding Sweetgrass, good book. Okay. The next question. Okay, I've had a couple people ask this question. So you mentioned that Scratch from MIT is great for like step one, learning the basics and the whys and the hows of programming. But do you have a suggestion for the next step after Scratch?
Okay, yeah. Well, I think Scratch does scale up
Oh, good.
pretty well. I still think Visual Basic is a good one as well, to learn those concepts as well, because it like has a drag or drop interface, which is great, but like you can also kind of like muck around with the like back end code. So I still like recommend that. I think Python and JavaScript are ones that you'll probably see the most. I think those are great, but I do think that having a background of the concepts will really help. You know, so I've definitely seen a lot of like kids coding Python books. And I think that that's probably the one that you could tie mostly into like careers of things like data scientists and data analysts and like as such. Yeah. So yeah, I would say Visual Basic and like some of like the early kids Python books, I think work, for like late elementary and like high school stuff
Cool.
is what I say for those.
Awesome.
And
Fun
JavaScript too. Sorry.
and JavaScript. Cool.
Mm.
Skype a Scientist runs on Python. Our whole matching algorithm is Python. So that's all I can contribute there. I didn't write. Okay, from Jaden, as a high school student, I was wondering what are some things that you did as a student outside of school that helped you find what career you'd like to follow and what you're passionate about?
Ooh, very good question. Yeah, so I went to the YMCA for many, many years over the summer. And the YMCA in my city, which was in Patterson in New Jersey, um, had a lot of great programs like arts and crafts I really liked. And there's obviously a science behind mixing colors and what colors that you get. And I remember making that like connection, like it was actually a counselor there that actually made that connection. It kind of blew my mind. I was like, whoa, are you serious? There's science in painting. So every time every time we went on like a field trip, I always made sure to like try to like think about what like the differences here are are like from where like I live, right? So like I grew up in New Jersey, so a lot of like our field trips were to like the Museum of Natural History in New York, or the Met, or the Statue of like a Liberty. And I used to always want always wonder like how do they make sure the Statue of Liberty doesn't fall over, you know,
Yeah.
or or like how did it get here? Because I knew that like it was a gift from France. So I was like, how did they get here? You know,
Yeah.
at well, one of my favorite parts in like of the Museum of Natural History is in the aquatic section. They have this huge whale that was like hanging on the ceiling, and like I was always like, how did they get that thing there? You
Yeah.
know? So like just thinking about those early questions, that curiosity, and making sure that if like you are a parent, stoking that curiosity and making sure that kids never feel ashamed for asking questions.
Yeah.
Even though I'm sure it's probably annoying if you get tons and tons of like questions. I'm not a parent, so I can't speak from experience, but I know that from my friends that are parents, some of them have some very inquisitive kids, but just making sure that you're never making them feel bad about it. Because I do remember being in like some classes where I felt ashamed if I asked a question about something, and that's really where science really like that's really where it comes from, is that curiosity and like making sure that um that that like someone is like eventually given the tools to follow up on that curiosity.
Yeah, I think I've heard from many scientists over the years, communicating with all of them and being a scientist, like the most important like personality trait in a successful scientist is not like being brilliant, it's curiosity. If you're a
Yep.
curious person and you're persistent, you're going to be a good scientist, because that's what drives us. That's so important. Yeah, so
Yes.
fostering curiosity. All right. Griffin, age 5, would like to know, what's the most surprising thing you've learned from being an engineer?
Hmm. I'd say the most surprising thing that I learned is that you can learn as much from uh, getting something wrong than getting something right. So one thing about science is you're going to get more things wrong than you get right. And I don't care how good of a scientist you are. Like, you know, um, you have to go into things, and if something like messes up, not get frustrated, right? Just like look at your notes and like try something new, right? But like making sure that you are documenting like your processes. So I really learned that, if you mess something up, or you blow something up, or you melt something, all things that I've dealt with, or you shock yourself, all that great stuff in
Yep.
the lab, that those are all learning experiences. So I used to get down on myself if I couldn't get something on the first try, because it's like, oh, I was such a good student, why can't I get this?
Right.
but that's still learning, you know. So like that's probably the like biggest thing that like I learned, and I use that in pretty much every aspect of my life, you know, is making sure that you can persevere through through like things that might not go the way that you originally planned.
That's so important. Yeah, I completely stand by that. Yeah. Failure is built into science. And it's not, you're not a failure when you fail. It's just part of it. And that's okay. Yeah. So again, about that shame thing, like don't feel ashamed for being curious. Don't feel ashamed
Yep.
for failing. Um, our society is very like, there's a lot of shame all over the place, and it's not super helpful in a lot of, particularly in education. So thinking about that in your classroom is great. Okay, so it is 1:40. We still have lots of questions, but we try to keep these to 45 minutes. So we've got 2 questions to wrap up here. The first question is, if you had everyone's attention in the whole world and you could tell them one thing about your area of expertise, what would you tell them?
Everyone's attention, huh? Everyone.
You got a
I would
powerful moment.
I would tell them if they don't mind paying off my college loans. No, I would tell them. No, I would. Wait, can you repeat the question? I'm sorry. If
you have everyone's
if I could tell them
one
one
thing
thing,
about engineering, what do you tell
okay,
them?
I would tell them. I mean, kind of repeating what I said earlier, but I would tell them like, you know, don't be afraid to fail.
Great.
You know, I really think that that's kind of understated a lot of times when like people talk about um STEM careers, but you really can't be afraid to fail. Like if you're afraid to fail, then like you're gonna have a much harder time having a career. And I mean that extends beyond STEM careers as well, but I think it's specifically, for my experience, I think that that holds true for engineering.
Awesome. Um, and then the second question is, you still have everybody's attention in the world. You can tell them one thing about anything. It can be as important, big picture, or silly and insignificant as you'd like. What piece of information do you impart on the world?
It's so funny because I keep thinking of and I promise I won't spoil this, but like there's a scene in the latest Wonder Woman movie where someone has the attention of the entire world, and I keep thinking about that scene when you ask these questions. But okay, so yeah, so I would say assume others' intentions are as good as yours. That's what I would end on. I think a lot of times we don't give enough grace to other people. Like if we do something that doesn't end up right, our first thought is, well, we intended it to be right, right? So like, give me a break. But if somebody else does something wrong, there could be a propensity to like get at that person, like, oh, why'd you mess this up? Like blah blah blah. So I almost feel like if we give other people the same grace that we give ourselves, I think that would make a big difference in the world. So that's what I would end things on.
I think that's a great way to end this. That's an answer that I really, really wish everyone in the world could hear. Because yeah, we gotta work together and build coalitions to make everything better.
Mm-hmm.
And yeah, giving everyone grace and assuming good intentions is a good idea. Okay, awesome. So is there anything you'd like to plug, anywhere that we can find you on social media and the internet broadly, before we wrap up?
Mm-hmm. Yeah. So my main website is shareefjackson.com, SHAREEF Jackson.com. And I'm also under that username Shareef Jackson on all social networks. So Twitter, Facebook, Instagram, all that stuff. My website has links to all the other stuff that I do. As I mentioned earlier, I started up a YouTube series called Equation Play, which focuses on science in games, which you could find at equationplay.com. I also have a YouTube series on diversity in video games called Gaming Looks Good. And my math tutoring service, my maths and science, the business that I founded is mathlooksgood.com. So all of that is at my website. If you're into tabletop RPGs, I do a weekly Dungeons and Dragons stream called The Rivals of Waterdeep at twitch.tv/Rivals of Waterdeep, which also has like a YouTube page and a Twitter and all that stuff. So if you're into D&D, make sure to check that out as well.
Awesome. You're doing so much cool stuff. It's just amazing. That's awesome. I'm so glad that you were on with us today. I've learned a lot and had a great time. So I hope you did too.
Thank you.
Yeah. All right. Well, everybody, thank you for joining us today. As an update, on Thursday at 1 p.m. Eastern, we're going to be talking about how old rocks are with Peter Martin. So please join us for that. You can find out the information on that on our Twitter. That's at Skype Scientist, or on Instagram at Skype a Scientist, or on skypeascientist.com. And also, if you appreciate the stuff that we do at Skype a Scientist, we're a nonprofit. We pretty much completely rely on donors to support us. So like small donations. This is a grassroots group. So if you can support us at even like $3 a month, that's so helpful to keep this program going. That's patreon.com/Skype a Scientist. Supporting us means the world to us, and we're hoping to maybe hire another person in addition to me in 2021. So supporting us would be amazing. Thank you again, Shareef, for joining us. Thank you, Erin, for signing for us. And we'll see you all on Thursday.
Thanks. Bye.
Thanks. Bye.